Okay, so what I did is I created a function, a linear function. It could be any function, but linear functions are easy to see the relationship that I'm trying to get you to understand. So that's why I did that. And then what I did is I had it graph the inverse. Now, something you probably did in pre-calculus or algebra 2 or college algebra is they had you find inverses. So if this is the original function, I can rewrite the f of x as y. So y equals 2x plus 1. Then to find the inverse, we remember the inverse function undoes the old function. So I'm going to switch x and y. Here, I'm going to write this in red. I'm going to write this in blue ink, and you'll see why here in a minute. So I'm going to switch x and y. So x equals 2y plus 1. I'll subtract 1 equals 2y. Then I divide by 2, divide by 2, divide by 2. So the inverse is y equals 1/2 x minus 1/2. So if you look at this blue graph, see, that's -1, that's -2 based on the scale. So you see how the y-intercept is -1/2, and that has a slope of up 1 over 2, up 1 over 2, up 1 over 2. See how that slope is 1/2. This original slope was 2. So the relationship is for inverses is that the derivative, the slope of the original function, and the derivative or the slope of the inverse function are reciprocals. And of course, with the line, they're always the same slope, so that's not such a big deal. But what they're going to ask you, and I'm going to show you an example of this in a minute here, or the My Open Math assignment, a question that's like this will show you an example like this. So what if I want you to find what's f prime of 0? Well, f prime of 0 is going to be this 2, right? That's the slope of 2. Then we're going to ask, what's f inverse prime of 1? Well, see how the old x and the old x and the y there, and the new y becomes what we're finding here. So I knew the slope here. If I wanted to find the slope here, now I want to find the slope here on the inverse. See how this is now 1, 0, how I switch the x and the y? Well, the slope of this line is 1/2. And we could say, well, it's just the reciprocal of the original. So here's something that's more like what I'm going to ask you, certainly in that first one. They're telling me that the function is, when x equals 3, y equals 5. And then I'm telling you the derivative of that original function when x equals 3, and that's -2. Then they're asking us, what's the derivative of the inverse function when x equals 5? So do you see how the old y became the new x? So when that's happening, f inverse, so I know that f inverse of 5 equals 3. See, x and y switch. But what I'm trying to find is what's the derivative of the inverse function at x equals 5? Well, we already know from that work I did a minute ago is that the slopes are just reciprocals. So since the slope of f of 3 is -2, the slope at f inverse slope, or f inverse, the derivative of f inverse at x equals 5 is going to be the reciprocal of that. So -1/2. Notice it's not the negative reciprocal, it's just the reciprocal. Okay, so that's what you do. And we don't know, we don't know what kind of function this f function is, but this relationship will hold, okay? So I'm going to reiterate, it's this old y usually becomes the new x that we're trying to find the derivative of. And the functions have to be inverses, so all you gotta do is take the reciprocal of the slope there. Okay, hopefully that helps.